Our planet is facing a crisis of our own making. We have become addicted to plastics. These materials are in almost every aspect of our lives, but their very durability poses a problem. Plastics can last for centuries, polluting our oceans and landfills. Imagine a world where plastics disappear naturally. This is the promise of bioplastics, materials engineered to break down completely. By harnessing the power of nature, we can create a future where our dependence on plastic doesn't cost the Earth. The development of sustainable materials is no longer a choice, but a necessity. Bioplastics represent a bold step towards a more sustainable future. They offer a chance to reimagine our relationship with plastics and mitigate the damage we have inflicted upon our planet. Together, we can turn the tide on plastic pollution. Bioplastics, simply put, are plastics made from renewable biological resources. Think of plants like corn or sugarcane, or even waste materials like food scraps. These resources are transformed through ingenious processes to create materials that resemble traditional plastics, but with a crucial difference: biodegradability. Unlike their conventional counterparts derived from fossil fuels, bioplastics can decompose naturally. Microorganisms present in the environment break them down into organic matter. This process leaves behind no harmful microplastics, making them a far more eco-friendly alternative. The science behind bioplastics is fascinating. It involves converting the sugars present in plant matter into polymers, the building blocks of plastics. The resulting bioplastics can be molded and shaped just like traditional plastics. Bioplastics encompass a wide range of materials with varying properties. Some common types include PLA, PHA, and starch-based bioplastics. Each type has unique characteristics that make it suitable for specific applications, from packaging to medical devices. PLA, or polylactic acid, is a versatile bioplastic derived from renewable resources like cornstarch or sugarcane. You'll often find PLA used in food packaging, disposable cutlery, and even 3D printing filaments. Its biodegradability makes it a popular choice for single-use items. PHA, or polyhydroxyalkanoate, is another exciting bioplastic produced by microorganisms. This bioplastic finds applications in various fields, including packaging, medical implants, and even agricultural films. Starch-based bioplastics, as the name suggests, are derived from starch extracted from crops like corn, potatoes, or wheat. Their biodegradability makes them a more sustainable alternative to conventional plastics. The most significant advantage of bioplastics lies in their potential to mitigate plastic pollution. Unlike traditional plastics that linger in the environment for centuries, bioplastics decompose naturally. This reduces the accumulation of plastic waste in landfills and oceans. The use of bioplastics also contributes to a smaller carbon footprint. By utilizing renewable resources, we reduce our reliance on fossil fuels, the primary source of traditional plastics. This shift towards renewable feedstocks helps combat climate change by lowering greenhouse gas emissions. Furthermore, bioplastics offer a pathway towards a circular economy. In a circular economy, materials are kept in use for as long as possible, reducing waste and resource depletion. The widespread adoption of bioplastics has the potential to transform our relationship with plastics. While the promise of bioplastics is undeniable, several challenges need to be addressed before they can fully replace conventional plastics. One significant hurdle is the cost of production. Bioplastics are currently more expensive to produce than traditional plastics, which hinders their widespread adoption. Another challenge lies in the performance of some bioplastics. While many bioplastics exhibit comparable properties to their conventional counterparts, some may have limitations in terms of durability, heat resistance, or barrier properties. Furthermore, the infrastructure for bioplastic production and disposal is still under development. Public awareness and understanding of bioplastics are also crucial for their successful implementation. Despite the challenges, the future of bioplastics appears bright. Ongoing research and development are continuously improving the properties, reducing the cost, and expanding the applications of bioplastics. Furthermore, government policies and regulations play a crucial role in promoting bioplastics. Incentives for bioplastic production, taxes on conventional plastics, and stricter regulations on plastic waste can create a favorable environment for the growth of the bioplastics industry. Consumer demand for eco-friendly products is also driving the adoption of bioplastics. The future of plastics is moving towards a more sustainable and circular model. By embracing innovation, supporting responsible policies, and making conscious consumer choices, we can pave the way for a future where plastics no longer pose a threat to our planet.